Welcome to this Back to Basics tutorial video which focuses on the original ASAP-1 analog system. The ASAP-1 is an ideal machine for backside thinning and has the ability to produce accurate, reproducibly thinned and polished dies. The standard 6-step process demonstrated here on an overmolded plastic package yields a polished surface suitable for backside microscopy. We have the main power with on-off button. The timer, the process start button, table speed with the table motion on-off, the tool speed with the tool spindle on-off. We have the Y amplitude adjust on the front and the X amplitude adjust on this side. Up here we have the XY tilt adjust with the Y tilt and the X tilt controls. Here are the controls for the micro adjust XY stage used for fine centering. We have the analog height indicator for the floating head and the floating head lock. We have the Z direction micro adjust. Over here is the locking screw for the slippable scale. This is the lock for the milling head. The entire head can be moved to coarse adjust the center of the milling operation. Then we have a camera which you can see on the monitor on the video 2 input. Video 1 is for the ULTRACOLLIMATOR. The accessory kit includes necessary setup tools and accessories. The external height indicator stand provides Z direction measurement throughout the process. A set of loading weights is supplied to add additional pressure when required. There are several parameters of the package device that should be known before starting backside prep. You will need the chip dimensions with its length, width and thickness. You will also need cross-sectional information like the thickness of package layers and the copper paddle or heat sink thickness. Many of these parameters can be obtained by X-ray or cross-sectioning an identical sample. From these parameters, you can determine the size of cavity you will need for the process. Use heated crystal wax to mount the sample to the plate with the supplied engineering square, or use wafer holders. Mount the plate onto the ASAP-1 using the locator dowels and fasten the locking screws. This is the X tilt adjust and this is the Y tilt adjust. After adjusting for tilt, center the sample using the floating head for coarse centering. The XY micro adjust is used for the fine centering. A dial indicator and the brass pointed tool allows you to set the precise center in X and Y. After centering the sample, set the amplitude of oscillation by loosening screws in the X and Y directions. This determines the size of the cavity that you want to open during the process. Rastering the table over the part shows the cavity that will be created. Step 1 is the Decap process with a coarse diamond tool. Mount the tool. Use the floating head to find the surface. Then set the Z-scale to 0. Apply extender fluid to the sample for the removal of material during this step. Set the tool speed to 3 and the table speed to 3 and start the process. Remove material in increments of 100 microns. Once you have removed the desired amount of material, you will arrive at the copper paddle. You can now clean the sample and move on to the next step. Step 2 is the heat sink removal process carried out with a milling tool. Follow the same procedure to mount the tool into the head and to find the surface. Be sure to zero the tool. The milling operation should generally be carried out with a locked head. Apply water and press start. Remove the material in increments of 10 or 20 microns. Once the chip is visible, the copper removal is complete. You can clean the sample and move on to the next step. Step 3 is the silicon thinning step with a fine diamond tool. Use the same procedure for setting the slippable scale to 0. In this step, the head should be unlocked. Apply extender fluid. Start the process. Remove material in increments of 20 microns. After the desired depth is reached, the process is then complete. Clean the sample. Step 4 is the pre-polishing of the sample with a xylem tool and blue diamond paste. Apply the blue diamond paste onto the sample. With a drop of extender fluid. Lower the floating head until it touches the surface and bring it down to achieve around 30 microns of applied pressure. Set the timer to 10 minutes or 600 seconds. Press start. Once the timer runs out, the process is complete. Clean the sample thoroughly to remove all traces of blue paste. Step 5 is the intermediate polish step. Carry out the same procedure as in step 4, but using a separate xylem tool and applying the yellow diamond paste with a drop of extender fluid. Lower the floating head. Apply 30 microns of pressure. Set the timer to 10 minutes or 600 seconds. Press start. Once the timer runs out, the process is complete. Again, remember to clean the sample thoroughly, making sure to remove all traces of yellow diamond paste. Step 6 is the final polish with Zybove tool and colloidal silica. Insert the tool and put a few drops of colloidal silica onto the sample. Lower the floating head. Set 30 microns of applied pressure. Set the timer to 5 minutes or 300 seconds and press start. When the timer runs out, the polishing process is complete. Clean the sample thoroughly. If a mirror finish is observable on the sample, you can move to backside imaging. At a few hundred microns thickness or less, dependent on dopant levels, silicon becomes transparent from the backside when viewed with near infrared light. The ultracollimator allows the user to produce the finest results of sample parallelism with both flat lapping and selected area preparation machines. It uses optical alignment that allows for simpler, faster, and significantly more accurate alignment to be achieved on a range of sample types. The ULTRACOLLIMATOR uses an intense light source that reflects off the backside of the silicon die and can be compared to the reflection from an optical flat. This allows for a more accurate way of aligning the chip to the polishing surface. It also allows the ASAP-1 to delayer a localized area of circuitry. ARC coatings improve the image contrast up to 60% on backside images. Emission sensitivity is improved up to 30%. This is helpful for emission microscopy and crucial for laser analysis. Key features of the ARC-lite system are that coating times are short, generally 45 seconds. Mount the sample with double stick tape on the mounting plate. Put a few drops of imaging fluid onto the sample. Cover it and lock the lid of the machine. Set the timer for the desired time, then press start. Coating is done at room temperature, where the system is on a benchtop and can sit alongside ASAP-1 and/or the microscope. When the timer runs out, take the sample out and it is now ready for imaging.
The original ASAP-1 was launched in the year 2000 and provided the FA sector with the first truly benchtop way of doing quality decap and backside preparation of packaged devices. At the time of launch, most of the devices were overmolded plastic packages, wafers, and a variety of ceramic packages. ASAP-1 sold in large numbers and remains a favorite of sample prep labs. Over the last 25 years, a great deal has happened in semiconductor design and packaging methods. Ultratech has stayed engaged throughout these technological innovations, and we continue to develop leading solutions for decap, backside thinning, and polishing. This year, we are proud to introduce the latest version of the ASAP-1 In Situ, the digital descendant of the original ASAP-1. In Situ continues the ASAP-1 legacy, but with many times the accuracy. This includes digital high-definition cameras, a fully automated tilt stage, image overlay, and an ever-expanding feature set. Please take a look and compare the specifications of where we were in the year 2000 and where we are today. We look forward to meeting you and to discussing all your sample prep and decapsulation needs. Thank you for your time.